Okay, we have for today an interesting integral. We've got the integral from 0 to pi, sine to the 11th, e squared tan x dx. Okay, this has a lot of intimidating parts to it. Like, we don't really want to reduce sine to the 11th. We don't really want e squared inside of the sine, and we don't really want tangent inside of the sine. Now, I actually don't really know if there's a long way to do it and like do it out. I don't really know if you could just do straightforward methods. Now, one other way you could do it is you could do it with King's principle, and that would be fine. But I think there's a little shortcut if we do this with Queen's principle. Okay, so we have our formulas over here to the right. We can use this two different ways, but it's going to be the same check. We want to check this f of 2a minus x value, where it's really, where we're going from 0 to 2a. It's just like King's principle. We're just going to be plugging in the sum of our upper bound and lower bound. So in our case, if this is all f of x, then our f of 2a minus x, then in our case, this is just going to be f of pi minus x. And with this, we're just looking for two different kinds of results that can help us. If we get back f of x when we do this, then we just take the 2 off of it. We split the bound in half and bring a 2 out front. If this is equal to minus f of x, the whole integral is 0, and we're done. The reason this is so fast sometimes is it's usually easy to remember the supplementary angle formulas, and if you get 0, you're done. So oftentimes you can, so when this lines up right, you can do the integral. Like in this one, you can do it in like 2 seconds. So let's just do this check. So we want to find f of pi minus x, plug in, we have sine to the 11th, e squared, tan pi minus x. But the supplementary angle formula on tangent, tan pi minus x is going to be just minus tan of x. But then because sine is an odd function, and let's just be careful about the 11th power, so I can bring the minus sign in front of the sine. We can write it as minus sine e squared tan x all to the 11th. And then from here, the key, we have, this is an odd exponent here, so like minus 1 to an odd power, we can bring the minus all the way in front. We have sine, put the 11th back, e squared tan x. But this thing right here is just this with a minus sign, so this is our minus f of x. And so it's this second check that works. And so we go right to our solution, get a 0. Okay, that's it for today. Thanks everyone for watching. Have a good day.